we have learned before for Van Everdingen-Hurst model, but this model is only applicable for edge water drive. So edge water drive means if you have an aquifer like that, your water will be on the edge of the reservoir, which is this part. But for a bottom water drive, so meaning that your oil water contact is fully here. So it all is coming from the bottom water, enter at reservoir bottom. We are going to use the CAC, Allard, Chen, Unsteady state model. So for this model, we take into consideration vertical outward flow of water, vertical permeability, and an additional dimension Z direction. So it's included here. So Fk, and then you have the Z direction. So the Fk is the ratio of the vertical permeability Kv over horizontal permeability Kh. So there are two directions of the permeability in here. And we will use this equation. For the dimensionless time, radius, and pressure, it is similar to VEH method. But for TD, you use 2.637 times 10 to the minus of 4 kT over porosity mu Ct R squared. And RD the same, R over RR. PD is the same. And we introduce a new dimensionless variable, which is for distance, ZD. So ZD is Z over RR, Fk 1 over 2 to the power of 0.5. And Fk is Kv over Kh. After we substitute those into the diffusivity equation, we can solve for this. And Allard and Chen, they solve this equation using a numerical simulator, while Coates, they solve it using a constant rate case for infinite aquifer. For this edge water drive, WE water inflow is the same formula, U delta P WED, but for aquifer constant U, it changes slightly different, and we have the height of the reservoir here. And WED is a function of R prime D and Z prime D defined below. So Z prime D is H over RR Fk power of 1 over 2, and R prime D is RE over RR. And we're going to use the same table. This is for finite table, and we also have infinite table.